Good morning, students. So in the last session we discussed about magnetic induction at the center of a current carrying circular coil. Now we are going to discuss magnetic induction at a point on the axis of a current carrying circular coil using Biot-Savart law. So the difference between this topic and previous topic is, in previous topic we calculated magnetic induction at the center of a circular coil. Now we are going to calculate magnetic induction at a point on the axis of a circular coil. So axis of a circular coil means, for example, let us say this is a circle and this is the center of this circle here. Now the line which is passing through the center of the circle, so this line indicates axis. So what is today's topic here? We are going to find out the magnetic induction at a particular point on the axis of a circular coil. So that is our today's topic. So here I have taken a circular coil here of radius capital R, and O is the center of the circular coil, and this line represents axis of a circular coil. Now on the axis of a circular coil I have taken a point P. So this point P is at a distance x from the center O. Now I have to take two DL elements, one DL element at point C and another DL element at point D. So these DL elements make 90 degrees with this radius vector, position vector. Now the distance between point P and C is this CP. So this CP can be calculated from the triangle OPC. So here the angle is taken as phi. Now from the triangle OPC, according to Pythagoras, the square of the hypotenuse equals to sum of the squares of the sides. That means square of this hypotenuse equals to r square plus x square. Then hypotenuse equals to root r square plus x square. That means root r square plus x square is the distance from point C to point P. Similarly, the distance in between point D and P also same, root r square plus x square whole square, whole power 1 by 2. So here same triangle OPD. So here length is x, here length is r, radius of the circular coil. So according to Pythagoras, this distance dp distance also same. That means the point P is at the same distance from DL element at point C and DL element at point D. Now apply the Biot-Savart law on this case. What is Biot-Savart law? The magnetic field dB equals to mu naught by 4 pi I dl sin theta by r square. So this is the Biot-Savart law. R is the distance between point and DL element. So here our point is on the axis here and DL element is here. So the distance between C and P is root r square plus x square, and theta. So theta is the angle between D element and this position vector, 90 degrees. So apply here. So dB equals to mu naught by 4 pi I dl sin 90 by r square. R square means distance square. So distance square of this one. So square and root will be cancelled. Then the remaining term is r square plus x square. Sin 90 is 1. So therefore dB equals to what? Mu naught by 4 pi I dl by r square plus x square. So dB equals to mu naught I dl by 4 pi r square plus x square. So that is the magnetic field at point P due to DL element at point C. So that dB direction is along this PE direction. So this is the resultant magnetic field at point P due to dl element at C. So this component will be split into two components. So one is dB cos phi along y-axis and dB sin phi along x-axis. Similarly, the magnetic field at point P due to small element length dl at point D is dB dash, and the remaining things are same. So theta also 90 degrees and distance also same. So same. That means dB is the magnetic field at point P due to dl element at C, and dB dash is the magnetic field at point P due to dl element at point D. So dB direction is along PE direction. It will be split into two components. One component is dB cos phi along y-axis and another component is dB sin phi along x-axis. Similarly, dB dash is along PF direction. So this also will be split into two components. One component is along dB dash cos phi along y-axis and dB dash sin phi along x-axis. Now, when you observe the diagram, dB cos phi, dB dash cos phi, both are along y-axis and they are completely opposite to each other. So these two components will be cancelled. And what are the remaining components? dB sin phi along x-axis and dB dash sin phi along x-axis. So these components will be added. So therefore, the resultant magnetic induction at point P due to this entire coil will be added. So this dB sin phi, dB dash sin phi will be added along x-axis. So therefore, the total magnetic induction at P due to coil is B equals to integral dB sin phi. So dB equals to dB dash equals to mu naught by 4 pi I dl by r square plus x square. So dB is the magnetic induction at point P due to dl element at C. dB dash is the magnetic field induction at point P due to dl element at point D. Both are equal because this point P has equal distances from C and D. So both are equal. So dB equals to this one. Substitute here. Then B equals to what? Integral dB. dB equals to what? Mu naught by 4 pi. Mu naught by 4 pi I dl by r square plus x square. Sin phi. How can you calculate sin phi? Here phi is the angle here. So how can you calculate sin phi from the trigonometry? Opposite side by hypotenuse. So what is the opposite side here? R. What is the hypotenuse? Root r square plus x square. Then sin theta equals to what? R by root r square plus x square. So therefore sin phi equals to r by r square plus x square whole power 1 by 2. Then simplify this one. So B equals to integral mu naught by 4 pi I dl r by, here r square plus x square whole power 1, r square plus x square whole power 1 by 2. So 1 plus 1 by 2, that means 3 by 2. So r square plus x square whole power 3 by 2. So again this can be written as, so mu naught by 4 pi I r by r square plus x square whole power 3 by 2. These are all constants because I is the constant current which is passing through the circular coil and dl element is the constant, the length of the small element dl is constant and radius of the circular coil is constant, and x is the distance between point P and center of the circular coil, that is also constant. So all constant terms take outside. So mu naught by 4 pi I r by r square plus x square whole power 3 by 2 integral dl. So integral dl. So integral dl means this entire length. So what we call this entire length? Circumference of a circle. So integral dl can be written as circumference of a circle, that is 2 pi r. So this can be written as B equals to mu naught by 4 pi I r by r square plus x square whole power 3 by 2. So integral dl means 2 pi r. 2 pi r. So this can be written as what? B equals to mu naught I. So your 2 pi, your 4 pi is there. 2. So that means mu naught I r into r square divided by 2 into r square plus x square whole power 3 by 2. So this is the magnetic induction at a point P on the axis of a circular coil, which is consisting of only one turn. If the coil is consisting of n number of turns, then the magnetic induction B equals to mu naught n I r square by 2 into r square plus x square whole power 3 by 2. So this is the magnetic induction at point P on the axis of a circular coil, which is consisting of capital N number of turns, and this is due to single turn. So this is the magnetic induction at a point on the axis of a current carrying circular coil by using Biot-Savart law. Thank you.